Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
Hi, I'm Dimitri.
We have here Michael from Netskope. Netskope here is the second time on the show, but Michael only the first time. Michael, can you please introduce yourself?
Thanks for having me, guys. I'm Michael Koyfman. I'm Principal Global Solution Architect with Netskope, and been with the company a little over 3 years.
Nice to meet you, Michael. Michael, let's start with the first question. What's the name of the product addressing the remote access by Netskope?
Our ZTNA product is called Netskope Private Access, and it allows our customers to seamlessly leverage Netskope platform to gain access to any application, no matter whether it's running in the public cloud, private cloud, or within the on-premises data center.
Michael, we're going to jump right to the offering, is to the architecture. Can you describe the architecture of Netskope to support private access, how it's working, and some of the nuances?
Absolutely. I'm going to share my screen. So as you can see here, on the very high level, Netskope operates in Netskope Security Cloud. And within the Security Cloud, we have a variety of security microservices. A core of our company was built on CASB. We were the original CASB vendor. We've extended into web as well as private access, which is what we're talking about today. So all those microservices are working in conjunction with each other to provide the various security and compliance and reporting functions. These clouds are dispersed all over the world. We have over 41 locations, and I'll show the map a little bit later. But in essence, what's happening is the users are connecting to the closest Netskope location to them, no matter where they are in the world. So I'm in Chicago right now. I'll be connected to Chicago data center. You guys are in Toronto. If you launch this product, it would be connected to a Toronto data center, etc. And the publisher, which is the Netskope component that connects your private applications to the Netskope Security Cloud, would be deployed very close to the application. So if the application lives in AWS, for example, it will be deployed in the AWS VPC. If it's in Azure, it will be in Azure. If it's in GCP, if you want this application to be in your own data center, you can deploy the publisher there as well. And based upon that application's location, the publisher will connect to the closest Netskope location. And this doesn't have to be the same location that the user is connected to, which is why it's important to see how all these unique orange lines and dots are dispersed around our cloud. Orange line here is the Netskope client, the user, no matter where they are, at home, in the office, at the customer side, etc. They are connected to the closest Netskope cloud to them. And then the publishers, which are providing access to these applications, are connecting to the closest Netskope location for that application.
Michael, does it mean that all the moment the connection hit the Netskope cloud is going inside Netskope backbone, or how does it actually going from a client all the way to the data center?
The connection, when the user is trying to access an application, they get a list of applications when they connect to the tenant, and the traffic is traversing the TLS tunnel right here between their endpoint and Netskope cloud, their Netskope cloud location that they're connected to. And then this location of the functionality is called a gateway. So once they're connected to gateway, the gateway will figure out where they need to go to. So the publishers connect to our New Edge cloud, and then the client will connect to the New Edge. And then the gateway will figure out where the application is that the user needs to access. And once it authorizes that user and verifies entitlement, it will discover which one of these publishers provides access to the application. And then it will stitch that connection, right? So it will route that connection to a stitcher functionality. A stitcher is the functionality of the platform where the publisher connects to and really stitches the connection between the end user gateway connection and the publisher that is deployed close to the application. So this allows you to have very high degree of resiliency and efficiency because you're not bound to have publisher connect to the same Netskope cloud location that the user is. They're connected to the closest, most performant Netskope security cloud location, which is New Edge. And then within our cloud, these connections are dynamically stitched based upon user entitlement.
So I have a question. When you mentioned publisher, is it something that functions like a reverse proxy?
Yes, sort of. It's actually not reverse proxy, it's a reverse tunnel, right? So the whole concept of zero trust is that you don't trust anybody, you're not opening up any ports. So the way Publisher works is it establishes outbound connectivity into the Netskope cloud. So you don't have to provide any inbound connectivity into the customer environment, whether it's the data center, whether it's the VPC and AWS, etc. All the Publisher needs is ability to connect outbound to Netskope cloud. And then client connections are sent over that reverse tunnel to the applications via the publisher.
And when you mentioned that you have 41 locations around the globe, these locations, they include your own data centers, or it's relies on public cloud locations only?
We could be here for an hour talking just about our New Edge network, but that's also one of the differentiators that we have. So we made a conscious decision to not rely on the public cloud. All of our data centers that you see on this map here, 41 and growing, are bare metal data centers where our racks are hosted in carrier-neutral facilities, where we bring various benefit providers in and optimize connectivity and peering with various providers to make sure the user's traffic is fully optimized from first mile to the last mile.
How do you license the product?
It's actually very simple. We license it per named user. So if you have 500 users in the company, you buy 500 licenses, and they can connect to the company private applications from any number of devices. So if every user has 2 devices, they can connect. They're covered in all the devices. If they have 1,000 applications that are private applications they want to connect to, they can access 1,000 applications. If they have 5, they can do 5.
You mentioned users. So how do I identify a user? Because I cannot really build a policy based on source IP. I have to use a user. I need to somehow to connect to single sign-on provider or multi-factor authentication.
Absolutely. And actually, I can do a quick demo of that. So I have a client here, which I will unenroll. And once you install a Netskope client that facilitates all this, you can enroll this client into the tenant. So I'm going to enroll the client into my tenant. And in this particular case, I have Okta, which is going to provide authorization and identity. And you can certainly complement this with MFA as well for strong authentication. I don't have MFA enabled right now, but it is certainly possible. So once I've authenticated to Okta, it would enroll the user and connect them to Netskope Data Center. You can see the client is on right now. So now I am fully connected. So I can go to...
When you say fully connected, you fully connected to the first POP, correctly?
I'm connected to the POP, right? I'm connected to my closest POP, and I'm connected to my private applications. So obviously, because I do a lot of modifications day in, day out, I turn client on, I turn client off, right? So what I'm doing is not necessarily indicative of what most people, what most customers are doing. Most customers will enroll the client into the tenant, and they will leave the client running all the time. Sometimes the customers may even disable ability of the users to disable the client, but usually when the client is enabled, it will stay enabled. If you reboot the machine, it will still become enabled after that, unless you explicitly disable it, right? So in some sense, it's VPN-like behavior like you're used to with VPN clients, but with the difference is that if it's on, it will persist to be on as much as it can.
When you now go to google.com, do you go through the tunnel, through the POP, or are you going directly?
I'm going directly because in this particular case, we're talking about private access. So private access is a private application. Now, this is not to say that you can't tunnel public applications through private access. You actually most certainly can. So I actually can tunnel google.com through private access if I wanted to for whatever reason. But what I'm going to show you is I'm going to show you that I can get into this application.
So I'm guessing if I want to use some other URL filtering solution to filter my outbound traffic, I can use it with the conjunction with Netskope Private Access.
Yes, you can certainly do that. However, you certainly will be introducing potential additional complexity because Netskope platform is able to provide full inline CASB and web filtering in the one platform with the same client. So
yeah, we actually, we introduced Netskope outbound browsing in season 1. I just wanted to understand if by any chance or somehow customer has two solutions, they can still use two at the same time.
Of course, yes. It's fully compatible with all other web filtering solutions, etc. Now that my client is on, I can go and access a private application. So I'm going to access this application. It's a WordPress that I'm running in California, AWS VPC. It's not accessible to the internet. This domain doesn't really exist, but I'm able to publish it to this client using any DNS namespace or even the private IP address. And I'm connected to this domain. And of course, the beauty of private access is that it's not bound to HTTP only. So if I need to SSH into this, I can SSH using my key into this server. And you can see I'm in the server, in AWS, everything is fine. And if I exit out of here, and let's say I'm going to stop my client. As soon as I do that, I'm going to try to do this again. You can't even resolve this host name because it doesn't exist. So this is how we allow customers to get into their own private applications without exposing them at all to the internet for inbound access.
Can you describe the end user access? We know about clientless with a client-based. Most of the people, they're relying on their browser to work. What are the options that your solution provides to such users?
Sure. So one of the prime reasons that private access exists as well as the VPN products is that there are many different ports and protocols that applications use. Most web applications are out there kind of using port 80, using published web servers, reverse proxies and whatnot, and any browser can get to them, right? So the primal focus of ZTNA and Netskope Private Access is to provide access to applications across all ports and protocols. So today we leverage Netskope Client for that functionality to do so. Clientless access is on our roadmap, so we'll be able to use the same authentication as you saw the client has leveraged to provide access through our new edge infrastructure to web-based applications, as well as some other applications that may be able to not leverage the client, but primarily it's obviously web applications. But today it's leveraging Netskope Client, which is a very tiny footprint on any device and allows you to seamlessly get access to any application and any port, TCP or UDP.
You mentioned ports. Can you talk a bit more about what type of ports you're covering? Can I do VoIP? Can I print? Can I do password reset?
Yeah, absolutely. So we cover all ports on TCP and UDP. So port 1 through 65.535, right? Doesn't matter. We don't do ICMP, for example, right? But ICMP is not really an application traffic. Now, the key thing to remember is a ZTNA solution typically relies on NAT, right? Because when you stitch all those connections, it certainly is impossible to preserve the original IP address of the client because it would be meaningless to the application, right? Because you're not really routing that IP address. It's not in the same segment, not in the same network, So all the connections that application sees are being sourced from the IP address of the publisher. And so because of that, the client is initiating all the connections to the server. And you mentioned VoIP, for example. So it really depends on the VoIP infrastructure. Some VoIP deployments are deployed in the way that require the two soft phones, for example, to talk directly to each other. And that is not possible in the world of ZTNA. So you need to make sure that you have something like session border controller deployed or some other equivalent in the network that can do NAT translation. But things like you mentioned, password resets, printing, anything that the client initiates directly, all applications and functions do work just fine.
And how the solution working on slow networks, or especially when the user roams between one network to another?
If you noticed, if I go back to my presentation, what's great is that the user is connected to Netskope data center here, and then the publisher is connected to a different location, right? So there is this decoupling that's happening. As the user moves around, they can reconnect seamlessly to the gateway and continue with their connection to the application. And also, because these are two independent connections, let's say you're doing a file transfer. Well, the publisher can be doing its own transferring and buffering to Stitcher. And then if the user is in a slower connection, then the network is taking care of window sizing and spoon feeding it here. So it doesn't really matter where the user is. Now, that said, one of the things that NewEdge does is it optimizes user path. We are trying to be within 50 milliseconds of any user worldwide. It doesn't matter where you are, we're trying to minimize latency, which maximizes throughput. But if you are somehow on a slower link or whatnot, we still give you the best possible latency and performance end-to-end.
So even if I change from Wi-Fi to 4G, I'm reconnecting to the first POP and I still maintain my connection.
Yep. We tie the connections to the user and the endpoint.
What would be the timeout for such connection? I'm assuming you're not keeping it alive for a very long time unless the user reconnects.
No, it's nailed up full time. Think of it as a VPN tunnel, right? If you have a tunnel, the tunnel is always on, and it's ready to take on traffic destined for the applications that are being serviced by this tunnel.
We have a bit different question about user behavior. I know a lot of vendors start to introduce more behavior analysis and reporting capabilities to understand from where you connect and if it's actually you. Can you talk a bit about what Netskope is doing in this scenarios about alerting, reporting, and user behavior?
Sure. So we do obviously track all the metrics around the user, what applications they use, how much data they transfer, etc. And it folds nicely with all the metrics that we collect around the user CASB and web behavior if the customer is using all three products within our portfolio. So then it folds in within our analytics platform where we're able to draw diagrams and see how the user is moving data, what applications they're accessing, what applications are even being used within the environment, right? For example, one of the big drawbacks of the traditional VPN solution is people say, hey, I just have my network open, right? 000, you can access everything. And so all you see are packets going. You typically don't log all the packets, you don't summarize them. It's really hard to get a full picture of what the user is accessing over your VPN connection. So if you take a step back for a second, the whole principle of ZTNA is to give the least privilege access, right? So the user is going to be connected just to the applications that they're entitled to use. But what we're finding out is customers, as they're trying to move into this direction, they don't necessarily know what those applications are. If you use a traditional VPN today, you're like, hey, I have my users coming in, they may be accessing 100 applications or 50 applications. I have no idea what it is. So how do I baseline? How do I know what applications I can define in Netskope? And so what they do with us is they kind of create this wildcard approach application where we tunnel all the internal traffic through private access. And then by virtue of that, we paint a picture of what applications, what hosts, what protocols and ports they use so they can turn this into granular application definitions for the least privilege access.
And can you later on alert about suspicious behavior for a user, for example?
Yeah, absolutely. We've been doing this for many years in CASB world, where if we notice, for example, a user is transferring files from one SaaS application to another, then we alert on that. So we can tie the private application user behavior, obviously, within that metric as well.
Thank you. We're actually done with our official questions, and we do have some time for free topics. So I do have some questions. and mainly about your architecture. I'm trying to understand more because you mentioned you have private data centers. So tell us a bit more, how do you scale? If there's a holiday season of everybody went from home.
One big secret about Netskope is that we standardize on building the bare metal, right? Some people that choose to go with the bare metal say, I have a server in somebody's rack, therefore it's a data center, right? We don't do that. Anytime we stand up a location, there's a full rack that goes in there that is full of equipment. So you have minimal capacity ready to serve hundreds of thousands of users at that location. And then we can expand it as needed, right? So, but we start fully over provisioned based upon data center. So, and then what happens is that as we add the locations, users automatically flow to different locations, right? Because, let's say Toronto location was there before Chicago. So I could be connected to Toronto because I'm in Chicago for my private applications. But as soon as we launched the Chicago data center, and this was like a year ago, right? But now I'm connected to Chicago, right? And I don't have to do anything because this is automatically handled by our Elastic Traffic Management. So now we've immediately increased capacity to the users that are closer to the data center that we launched. And like I said, initially we massively over-provisioned. So our utilization versus capacity worldwide is pretty astronomical ratio. Of course, if we have sign up large customer at a particular location that's taxing the capacity there, then we simply add capacity within the data center, add another rack, and the users are able to take advantage of the processing power.
I think you mentioned Elastic Network. Can you elaborate a little bit about that?
I mentioned Elastic Traffic Management, right? So the Netskope Global Traffic Management is the system that we use to dynamically distribute traffic across all the data centers that we have, right? So as we launch new data center, customers are automatically taking advantage of them because we dynamically distribute them based upon geolocation. So we triangulate the user's egress IP address, and we always send them to the closest Netskope data center location based upon where they are. And so it's all happening automatically. If the user moves from Chicago to New York, they don't need to obviously change anything. They'll automatically be connected to New York data center, etc.
Can you provide to a customer his own POP that he can host in his location, and having all of his connections going through this POP, this kind of on-prem solution?
Well, so the private access is really interesting, right? Because if you think about it, and let me go back to sharing. This is a little different from web, because the user comes into Netskope data center here, and then let's say they're stitched to the location here, to this publisher, and then it goes to this application. Now imagine that this is a SaaS application, right? Let's say this is publicly hosted SAP, no, commercially hosted SAP or Oracle, or let's say you go to SaaS here, it doesn't matter. What that application will see is the egress IP address of the publisher. So they will see like local IP address, and so the user owns the publisher, so they know which IP address the publisher will have. So if it's internal, it's going to be internal IP address. If it's the publisher that you want, so another way that people will do it is say, let's say that the user has here's a situation. Let's say the customer has agreement with a third party where they can only access those applications from the third party from their corporate network, right? They nail it up to the corporate IP addresses. So when the users are within the data center in the office, that's all great. Obviously it works. When they go home or in pandemic, obviously it's a bit more challenging. VPN. Right, exactly. So you use VPN, right, into the data center. And, once again, how do you do this? Now you VPN in, the user is able to access anything in the corporate network just because they need to get to this third-party application through your known IP addresses, right? So you can choose to deploy a publisher anywhere. You can do it in your data center. You can deploy a publisher in public cloud instead, just for the routing purposes, and then you know what your source IP address there is because you own it. So you can deploy a publisher into maybe a public cloud location, and because you own IP addresses there, you can allow them, ask your provider to allow these IP addresses to establish connections and treat them like your corporate IP addresses, and kind of provide this proxy known IP level access by your end users for those applications.
But once I deploy the publisher, no other traffic will flow through this publisher, even if it's in the public domain, right?
Yeah, it doesn't matter where the publisher lives, right? The publisher is establishing connection to Netskope Cloud, and the only traffic that will come via this tunnel to the publisher is whatever gateway is going to send there based upon the policy entitlements of the user.
But in this case, as example, right, in case of the private apps in public cloud, there is a publisher that's connecting it to Microsoft Azure, to GCP, to AWS, etc. And I'm assuming that many of your customers are using the same publisher to access these services because you're locating this publisher as close as possible to these public cloud providers, right? Now, if I'm running my own publisher, right, that allows someone to access my internal SAP system, or through my internal network to access external SAP system, I wouldn't like anyone else's traffic to go through this publisher. How do you enforce that?
Right, and that's what I was saying. This is a security fabric within the Netskope Security Cloud, right? So the publisher, when it connects, it's enrolled in your Netskope tenant, and it authenticates to a Netskope tenant. And so when it connects, it says, I'm the publisher for your tenant. And so it will only accept traffic from the users that are routed to that publisher for that particular tenant. So there's a mutual TLS authentication. The publisher enrolls, it has a cert that it presents, that authenticates it, verifies that it belongs to a particular tenant. And then the stitching capability between the gateway and the stitcher here is what authorizes and handles the traffic.
Michael, is there any bandwidth limitation for the publisher because all the traffic goes through the publisher towards the application?
Yeah, the publisher obviously has bandwidth limitations. I think today they are in a couple hundred megabits per second that you can push through a publisher, which is very lightweight publisher, and you can scale them so you can deploy like 2 publishers in active and load balance traffic across them automatically within our system. So you can scale them linearly. In the future, we'll have n number of publishers that you'll be able to deploy if you have some high throughput traffic. It's typically not something that we've encountered yet just because of the distributed nature of the applications. If you think about VPNs, traditional VPNs, you have a box and you have to have the box, monolithic device in front of your all applications because all the users have to connect to that box, right? But this approach abstracts all that, right? So all the user needs to know is they connect to Netskope Cloud, and then based upon what applications they need to access, the cloud routes them to the publisher, because when you create an application definition, you bind that to a particular publisher or publisher group. So you can create a publisher. If you have a high throughput application, you can dedicate a publisher or a group of publishers just to that application. And then for everything else, it can be served by a different publisher, even if it's in the same network location. Virtual machine, yeah, it's running containers, right? It's running in Docker, so very lightweight, Docker images that you deploy that handle all of this.
Michael, I have a maybe last question, or not even a question. Can you tell an interesting story about the implementation with the customer when you guys were able to overcome a particular problem that maybe wasn't expected?
Sure. I mean, the story is actually very simple. One of the use cases for private access is actually leveraging a tool like SCCM, for example, to provide patch management distribution to the endpoints that are off the network. And obviously it has become a certain big pain point in the COVID days because all the users are working remotely and the company still needs to manage software distribution and patching to these endpoints, and the VPN systems don't necessarily scale for that. So we have one very large customer that actually wanted to solve this problem. They've been an existing Netskope customer for a while, and they've been able to add NPA to their existing deployment, the same client. We deployed 3 publishers for them in 3 different geographic locations. Just like that, they were able to connect all their thousands of users, I think close to 40,000 different users across the globe to obtain their SCCM patches and software distributions.
Thank you. I think we come to our time as well. Anything else, Michael, you want to add?
No, that's it. Just wanted to say thank you guys for having me. It was great talking to you about our product, and I hope to talk again in the future.
Nice. We're definitely going to publish links to demo and POC and to your profile on our website as well for people that want to find you. Thank you very much.
Thank you, Michael.
Thanks, guys.
Please remember to subscribe to our podcast and join us for our next episode.